Hi students, how are you all? This is Rohith Kokkula from Light Rays Physics. In the previous class, we have seen the introduction part of reflection of light at curved surface. Now let us learn some of the terminology relating to this topic. So let me recall once again what is reflection. So the light which is coming from the light source falls on the object and it gets bounced back into the same medium. So this phenomena we regard it as reflection of light. The best example of reflection of light is shown here. The kid is seeing her face in the mirror. Now my dear students, let us understand some of the important terminologies to understand the reflection of light. So already we have discussed what is light, right? So what is light? So it is a form of energy which makes us to see the objects around us, right? And we have already discussed source of light. What's the source of light? Any object that emit light is called source of light. Now we will discuss the types of optical media. So what's the meaning of optical media? The medium which helps the light to propagate. We call it as optical media. So we have three types of optical media: transparent, translucent and opaque. So here I have mentioned with some examples. So this object is allowing the light completely to pass from it. So this type of medium we call it as transparent medium, means it will allow all the light to pass from it. The best examples are transparent windows and the pointed lens. I'm not calling about the Cooling lens, I'm calling about pointed lens. And you see here translucent optical medium, means this will partially allow the light. You see here we have three arrows indicating the amount of light, but you see only two arrows are coming out, means it's allowing a little fraction or a less amount of light compared to the incident light to the other side of the medium. So the best example is sunglasses. Okay, and the final one is called opaque optical medium. So you see there is no arrow towards the right side because it's not allowing any light. The best example is the book. Now let us highlight the below pictures. Now here we have three pictures. The central one is called convex mirror and the later one is called concave mirror, and this is plane mirror. All these objects won't allow any light to pass out of it. So all these are opaque substances. Now in this chapter we are going to study about all these things. Now my dear students, I want to introduce a special type of scale that is present in my tablet. You can see it on screen. So this is a special scale which has length which is positive towards the right side and length which is negative towards the left side. This scale can be rotatable too. You can see it on the screen now. The angle of this scale can be seen at the central part. So that is the angle. Now whenever I talk about the length, you have to see either to the right side or the left side based upon the value I take on the scale, whether positive or negative. Let us learn the basics of reflection of light from the beginning. Now I will take the scale and I will draw the baseline. Now I will draw some slants in the bottom of this baseline. So this indicates it's an opaque substance, means it does not allow any light to pass to the other side. Now I will take the scale and I will draw a line. The line or the ray which is coming towards the baseline or the interacting surface is called incident ray. Now at the point of incidence, if I draw a 90-degree line for the base surface, we call it as a normal. The angle between the normal and the incident ray is called angle of incidence. Here it is 60 degrees. Now this incident ray will fall on the object and will reflect into the same medium or bounce back into the same medium. Now the light ray which is moving away from the interacting surface after reflection is called reflected ray, and the angle between the normal and the reflected ray is called angle of reflection, and it is also to be 60. If you look carefully, angle of incident equal to angle of reflection. This is called first law of reflection. This was first explained by a scientist called Fermat. Hence it is called Fermat's principle. Now we will study about that Fermat's principle very cleanly with the help of an example. My dear students, I have taken this example from the 8th class physical science textbook of Telangana. So I am modifying a little bit of content to understand it even better than in textbook. If we observe the figure, we have two trees in the line MN. A crow is seated at point A and there are some grains on the line MN, means they are on the ground. The crow has to start from point A and it has to go to point B by taking a grain from the land from C, D, E, F points and so on. But the condition is the crow has to take the least time to go from point A to point B by picking up a grain. Let's say the crow started from A to C to B, A to D to B, A to E to B, A to F to B. But among the four paths in the line MN, which is the least path? That is, among the path 1, 2, 3, 4, the crow has taken one path as the least time taken to cover between A and B. But what is that path? How to know it? For that, let us take one more analogy. So here we have the points A, B and G. Let us measure the distance of B and G from the point MN. If you look clearly, the distance of B from MN is around 3.3 and the distance of G from MN is also around 3.3. It means that the distance between MN line to B and MN line to G are same. Now let us draw lines from F to G, E to G, D to G, C to G as shown in the figure. Now if you measure the lengths, FB will be equals to FG, EB will be equals to EG, DB will be equals to DG and CB will be equals to CG. If you observe all the parts, we are having the bend everywhere. You see at the point C we are having a bend, at the point D we are having a bend, at the point F we are having a bend. But we don't have a bend in the path A, E, G. Why? It's a straight line. Now, what is the shortest path to travel? A straight line, right? Now, we have seen the distance of E to G is same as E to B. Now, what I will do, I will draw a normal at the point of incidence, or the point at which the crow has taken the grain. Now see the angle here, it's 90 degrees, means we are drawing normal. Now I'm drawing the normal at the point E. Now this is normal. Now let's measure the angle. We have to measure with respect to normal, means we are going anti-clockwise. So whatever the angle we get, we have to remove it from the 90. So we have got the angle 30, means 90 minus 30 is 60. It means the crow is making an angle of 60 degrees in the path A, E, N. Now let's see the other side. Again it is 90. Now how much angle is it making? What is 90 plus 60? 150. Means the angle made by the crow here, it is 60 degrees. Now if you observe carefully, the angle AEN is 60 and angle NEB is also 60. Why? We all know that the straight line is the shortest distance. If you want to go with a shortest time, you need to go in a straight line. Now, is there any chance to come to the other end of the line? It's an opaque substance, right? It does not allow any light to pass to the other side. So what he has chosen, the crow has chosen the path such a way that if it goes in a straight line, how much amount of distance it could cover, it has taken the same length and went to point B. It means that to cover AEG, what will be the time taken? The same time will be taken for AEG. What is the length of AEG? The same length it has for AEB. So that's why we are getting angle of incidence equal to angle of reflection. So this is what explained by the Fermat. How the crow has taken the path A, E, B to go from A to B in the lowest time possible. In the same way, the light also chooses the path in which it will take the least time to cover between 2 points. That's why we get the output of angle of incidence equals to angle of reflection. So this is what explained by the Fermat in Fermat's principle. That is the reason why angle of incidence is always equals to angle of reflection. Now let us learn the second law of reflection. What is second law of reflection? It's very simple to understand. So this incident ray, normal and reflected ray all will lie in same plane. A plane is a 2D surface. Now if the light ray is coming and falling here, now if you draw a normal, the reflected ray will be in this direction. Now imagine you are here. The object is here. Now you can see the object clearly. But if you shift to the right or to the up, you cannot see because you are not in a plane. So this is about second law of reflection. So that's all for today. So in this we have understood some basic terminology and laws of reflection. In the next chapter we'll study about the curved surfaces, what they are, how they are produced, what is the intention in studying them and everything. Most importantly, how to understand the definitions and how to read the definitions, how to understand the definitions is a key play roller of tomorrow's class. Thank you students. Have a great day.